Okay, good morning. This is our lesson number 6, parallel circuits and current division theorem. So in this lesson, we will learn how to determine whether a circuit is in parallel or not, and how to calculate the equivalent circuit for parallel circuits, as well as the division theorem. So let's start. So for parallel circuits, suppose we have here a circuit with two resistances R1 and R2 connected in terminals A and B, and we are interested in solving for RAB. So how do we do this? So RAB is the equivalent resistance at terminal AB for a parallel circuit. So we will be talking about the properties of parallel circuit. But before that, let's label the parameters in the simple circuit that we have drawn here. So of course, we'll be needing the V1, the V2, I1, I2, and I total, and V total. So for a parallel circuit, the voltages should be equal across the branches. In other words, V1 is equals to V2 is equals to V total. Second property is that the total power is the sum of the individual powers, meaning the power at total is equal to P1 plus P2. Okay? And finally, we have the total current is equal to the algebraic sum of the branch circuit currents. So we will try to derive a formula for this or prove this particular concept by using the second property that we have discussed, that the power total is equals to P1 plus P2, and the first property, which is says that Vt is equals to V1 is equal to V2. So if Pt is equal to P1 plus P2, and we know that power is equals to voltage times current, then voltage are equal, so cancel na siya. So we have It is equal to I1 plus I2. So this is our third property. In general, for parallel circuits, the voltages are equal. The I total is the sum of individual currents, and the P total is the sum of the individual powers. Now, we will be talking about the property of parallel circuits in terms of resistance. So for total equivalent resistance, suppose you have here a circuit with R1, R2, and Rn, the R equivalent will be equal to, so we're now deriving the formula for resistances. We now know that the Ohm's law says that I is equals to V over R, and we substitute that with the third parameter or third property explained a while ago. Then we can just eliminate or divide out the voltages. Then we can derive a formula that says 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over Rn. So ito yung magiging general formula natin when it comes to parallel circuit for resistances. So therefore, R equivalent is simply equal to the summation of the sum of the reciprocals of the individual resistances connected in parallel. Okay, so now, what if we have two resistances in parallel? So dalawa lang. Anong gagawin natin? So we will still use the formula stated above. So 1 over R total is equals to 1 over R1 plus 1 over R2. And we will try to simplify this para mas maging madali for all of us. Since 1 over R1 plus 1 over R2 is two separate fractions, we combine them to a single fraction. Then we can get the reciprocal, and then we can get the formula that says R total is equals to R1 plus R2. Okay, now, we will be talking about the equal resistances in parallel. So, paano naman kung lahat ng resistances are in parallel are all equal? So, ang gagawin lang natin, sundan pa rin natin yung formula above, and then, since pare-pareho lang naman sila, we multiply it by the number of resistances na equal. And then, just get the reciprocal, then that is the formula. R total is equals to R divided by the number of resistances in parallel that are equal. So, for parallel connected identical resistances, the equivalent resistance is the value divided by the total number of resistances connected in parallel. Now, we can now move on to the current division theorem, or the CDT. So this particular theorem is very useful in calculating currents individual currents or the currents in each branch circuit connected in parallel. So suppose you have here the same circuit as above, R1 and R2, and then meron ka syempreng I total, and then hatiin siya to I1, and then meron ka ding I2. Paano natin susolve ang I1 and I2? So, syempre meron kang voltage, ano? So, titingnan natin. So, since we know that the voltages across each resistances are equal, then we can use that particular property and substitute the value of the current, ano? But we also know that the value of your resistance for parallel na dalawa lang sila is equal to RT is equal to R1 over R2, R1 R2 over R1 plus R2. And ngayon, itong particular formula na to, isusubstitute natin doon sa pinakauna nating ginawa, which is IT, RT is equals to I1 and R1. Ayan. So, kapag sinubstitute na natin siya dyan, makikita natin that R1 can now be divides out, no? So, ang matitira ngayon is I1 is equal to I total times R2 over R1 plus R2. So, makikita natin dito that if we use the same concept, ganun din ang result na kakaratingan natin for I2, which is equal to I total plus R1 plus R2. Okay? So, any question so far? And I hope na naigigets natin. So, in summary, we can only use this if the resistances in parallel are only two resistances. Kung tatlo na sila, hindi in parallel, hindi nyo na pwedeng gamitin ng CDT. Second, ito yung mga summary natin. IT is equals to I1 plus I2. I1 is equals to IT R2 over R1 plus R2. And then I2 is equals to IT R1 plus R2. So, this is the summary of the CDT. Now, we can look into an example so that we can try solving for parallel circuits using the properties already discussed, as well as let's have an example using the CDT. Okay. So, for example, 6.1, you have two resistances in parallel. R1 is equals to 6K ohm, R2 is equals to 4K ohm, and we have a supply current equal to 20 milliamperes. So, anong mangyayari ngayon? So, solve natin si I1 and I2. Let's try. We will use CDT later. But since nandito na din naman tayo, we will try to solve RT as well. So, ang required natin, A, RT, B, I1, CI2. So, for RT, gagamitin lang natin yung formula stated above. So, solution. So, for RT is equals to R1 plus R2 times R2 all over R1 plus R2. And then just substitute the 6K ohm, the 4K ohm. Ang result natin dito is equals to 2.4 kilo ohms. Since we know already RT, we can proceed to B, solving for I1. We will be using the CDT. So, solving for I1, CDT, I1 is equal to IT R2 over R1 plus R2. So, substitute lang natin ang values and then the result is of course 8 milliamps. So, that is the value of 8 milliamps. For I2, you can also use CDT. But since we already know that they are in parallel and ang total current natin is 20 milliamps, we can just use the property that says IT is equal to I1 plus I2. So, therefore, I2 is equal to IT minus I1 because of the same property na binanggit ko, just substitute the value. Then, we can solve for the value of I2 which is equals to 12 milliamps. So that's it, guys. I hope that you have learned the basic principle in solving parallel circuits and using CDT. So thank you and God bless.